Today we're going to explore completing the square of quadratics. Completing the square means rewriting a quadratic in the form x plus h squared equals p. Completing the square is very useful as it helps us to find the values of x when we can't easily factor. So let's see how this works. How can we find the values of x in this quadratic? We know that this whole thing equals 0, so maybe we could try factoring the polynomial. If we list the whole number of factors of 2, we get 1 and 2 and -1 and -2, neither of which add up to 4, the coefficient of x. So let's try something else. First, let's isolate the x's. To get rid of the 2, we can subtract 2 from both sides. Now, we take the coefficient of x, 4, and divide it by 2. This is 2. Now we square this and add it to both sides of the equation. So the equation becomes x squared plus 4x plus 4 equals -2 plus 4. -2 plus 4 is 2, so we can go ahead and simplify that. Now why did we add 4 to both sides? We added 4 because it ensures that the left side forms a perfect square trinomial, allowing us to factor easily. This is a bit tricky to explain, so let's visualize this. Here, we see our original equation. Now the quadratic on the left can be thought of as the area of a shape. X squared makes a square, and for the 4x, we can split this in 2, and add 2 rectangles to the sides of our square. Each of these rectangles has an area of 2x. Now if we rearrange this, we see that we almost have a square. All we need to do is fill the corner. But all we have left is 2, which isn't enough. To complete the square, we need a square with a length and width of 2, an area of 2 squared. So let's first get rid of the 2. And we already did this in the previous step where we isolated x by subtracting 2 from both sides. Now we add 2 squared, or 4, to both sides. And we've completed the square. Now here, I said the quadratic is a perfect square trinomial as it is one way to express the area of the square. But what is another way we could express the area of our completed square? Because all these sides of the square have a length of x plus 2, the area is the same as x plus 2 squared. So x plus 2 squared is another way we could rewrite our quadratic. Notice that the 2 is not random. The 2 was the length of the rectangles from before, which we calculated as half of 4, the coefficient of x. This helps us when rewriting the square. The constant in the square is just the coefficient of x divided by 2. In our example, we know that 4 divided by 2 is 2, so the quadratic x squared plus 4x plus 4 is the same as x plus 2 squared. Pretty cool stuff. And that's how we complete the square. Now once we've completed the square, we could go ahead and solve for x. How can we isolate x? Well, to get rid of the square, we can take the square root of both sides. Since the square root of any square is itself, the left would simplify to x plus 2. Now, on the right, we need to take both the positive and negative roots, since both the positive square root of 2 squared and negative square root of 2 squared are 2. To notate this, we can use the plus minus sign. Now all we have to do to isolate x is subtract 2 from both sides. So the solutions of x would be either -2 plus the square root of 2, or -2 minus the square root of 2. And that's it. We found the roots of this quadratic by completing the square. Notice that our roots are not whole number factors of 4, thus it would be pretty hard to guess them otherwise. Completing the square helps us to find the roots of quadratics that we can't easily factor, which makes it super useful and important. Okay, now what if the x squared in a quadratic has a coefficient? To complete the square, x squared must have a coefficient of 1. So how can we do this? To start, we need to divide everything by the coefficient, 3. Now, x squared has a coefficient of 1. To simplify the rest, 6 over 3 is 2, and 0 over 3 is just 0. From here, we can go on completing the square like before. First, we need to isolate x. To do this, we just need to subtract 1/3 from both sides. Next, we take the coefficient of x divided by 2 and square this. We then add this value to both sides. And after we've done this, we know that the trinomial on the left is a perfect square, whose constant is half the coefficient of x. So we get x plus 1 squared. On the right, to simplify, we need a common denominator. We know that 1 is the same as 3 over 3, so we get -1 plus 3 in the numerator, which makes 2 over 3 on the right. So we've completed the square. To solve for x, we just need to isolate. First, we need to get rid of the square. This can be done by taking the square root of both sides. The square root of a square leaves us with whatever is under the square. On the right, we have the square root of 2/3, and let's remember to use both the positive and negative roots. Okay, so now we have x plus 1 equals plus minus the square root of 2/3. To simplify here, we just subtract 1 from both sides, and that's x. -1 plus the square root of 2/3 and -1 minus the square root of 2/3. And there you go, a little introduction to completing the square. To get more familiar with completing squares, you can check out this video, where we'll complete the squares of some more quadratics. And that's all for now. If you learned something or enjoyed this, like and subscribe, and share it with a friend who's stuck on finding the roots of quadratics. Alright, keep working hard and keep learning. Thank you for watching.